Hello everyone and welcome to our engineering talk show. Today we will explore how differentiation and integration are used to solve real-world engineering problems. Mathematics is not only about equation and calculation, it plays an important role in helping engineering design and optimize and improve different systems. In this episode we will discuss two engineering applications. That first one is rescue drone flight, optimize where differentiation is used to find maximum height of the drone. The second one is a blood transfusion system where integration is applied to calculate the total amount of blood delivered to a patient. We are joined today by engineering who will explore how these mathematical techniques were applied to solve this problem. I have here two.
My name is Amir Awadallah. My student ID is 0379568.
My name is Mazin, Haider. My student ID is 0379348. Both of us are
aerospace engineers.
Introduced to how to biomedical engineering. Let them introduce themselves.
Hello, my name is Muhumed and my student ID is 0390677.
My name is Zaidan and my student ID is 0391692 and we are both
A biomedical engineer in the same.
Our first topic is about differentiation. That's used to study how quantity change. Engineers often use it to find the maximum or the minimum value function, which helps us to improve the performance and efficiency of many engineering systems. In this example, we worked on a rescue drone used after an earthquake. We determined the maximum height the drone could reach, allowing it to cover a larger search area, maintain a stable communication signal, and help to locate and rescue as many survivors as possible. The height of the drone is modeled by this equation right behind it. H of 2 equals negative 2t squared plus 16t plus 5, where the h of t refers to the height in meters and the t refers to the time in seconds. To find the maximum height of the drone, we use differentiation. By calculating the derivatives and finding the critical point, we can determine the exact time when the drone reaches at its highest point. Now I'm going to pass it to our aerospace engineer to continue the calculations.
For this part, we're going to differentiate to find the critical point, which is the time. So first off, we're going to differentiate the minus 2t squared, and for that derivative would be minus 4t. Moving on to the next one, which is 16t, and the derivative for that would be 16. And for the last part, which is 5, it's a constant, so the derivative will be 0. And now, in order for us to find the maximum height, we have to find the critical point, which is the time. And for that, we have to leave the derivative set to 2 equals to 0, so derivative of 2 equals to 0. And we move the 16 to the other side, and then divide everything by negative 4. And that is t equals to 4 seconds. And the drone reaches its maximum height after 4 seconds. Now we have to find the maximum point after we got the critical point. And for that, we have to substitute the critical point into the original equation. And by doing that, we're going to be h of 4 is equals to minus 2. 4 we're going to substitute instead of t, plus 16, 4, plus 5. And then we'll solve for everything, as you guys see. And finally, we'll have the final height, which is 37 meters. Therefore, the drone reaches the maximum height of 37 meters after 4 seconds. This helps engineers identify the optimal height of the rescue operation. And now, moving on to the next question.
Now, let's move on to our second engineering question, where we are applying integration. Now, what is integration? Integration is used to calculate the total amount of a changing quantity over a period of time. Engineers use integration in many systems where values are not constant and change continuously. Now, in this case, we are using integration in a blood transfusion system where we are using an advanced infusion pump. Basically, in a treatment like this, blood flow is pumped over a rate of time. Okay? Usually, it would take around 1.5 to 4 hours, but since since we're calculating in minutes, we have minimized it to around 8 minutes. This is the blood flow rate model. RT is flow rate in milliliters per minute, and T is time in minutes. So our goal here is basically to calculate how much blood is pumped in a certain amount of minutes, which is 8 minutes. We're calculating now. Now I'll pass it on to Salma My other engineer.
Now to calculate the total amount of blood delivered, we use defined integration. Our defined integral will be from 0 to 8 to 10 plus 14 negative minus 0.5 t squared respect to t. So the integration term by term will be for 10 to become 10t, and for 40 to become 2t squared, and for 0.5 t squared it will be t cubed over 6. And then we will apply our limits from 0 to 8 into the equation, and we'll substitute it. Okay, so now we will substitute 0 and 8 into the equation, and we will get 122.67 milliliter, which is the amount of blood that was delivered in the first 8 minutes. This result helps the biomedical engineers make sure that the infusion form delivers the right amount of the blood safely and accurately, which will help the treatment of the patients. Thank you.
Thank you to our engineers for explaining how differentiation and integration help solve real-world engineering problems. Today we learned that differentiation helps optimize system by finding maximum or minimum volumes, while integration helps calculate total quantities that change over time. These techniques are important tools that help engineering create safer and more efficient solutions. Thank you for watching.